In our previous session, we have discussed with the RC airfoil design and how it is linked to the wing of aircraft. Now, let's begin with the motion of flight. Have you ever thrown a frisbee? It flies because of four forces. These same four forces help an aeroplane to fly. The four forces are lift, thrust, drag, and weight. As a frisbee flies through the air, lift holds it up. You gave frisbee thrust with your arm. Drag from the air made the frisbee slow down. Its weight brings the frisbee back to earth again. Wings keep an aeroplane up in the air, but the four forces are what makes this happen. They push a plane up, down, forward, or slow it down. Thrust is the force that moves an aeroplane in the direction of the motion. It is created with a propeller, jet engine, or rocket. Air is pulled in and then pushed out in an opposite direction. Drag is the force that acts opposite to the direction of motion. It tends to slow an object. Drag is caused by friction and differences in air pressure. Weight is the force caused by gravity, downward force. Lift is the force that holds an aeroplane in air. The wings create most of the lift used by aeroplanes. The way the four forces act on aeroplane makes the plane do different things. Each force has an opposite force that works against it. Lift works opposite to weight, thrust works opposite to drag. When forces are balanced, a plane flies in a level direction. The plane goes up if the forces of lift and thrust are more than gravity and drag. If gravity and drag are bigger than lift and thrust, the plane goes down. Now, let us discuss the propulsion system of aircraft that helps to produce lift. These are of two types. First, the piston engine. Intake. To begin the cycle, a fuel mixture is introduced into the cylinder through intake port, expanding the piston to the bottom of the cylinder. Compression. The piston then gets pushed to the top, compressing the fuel mixture and igniting it via a spark plug. Ignition. The ignition pushes the piston downwards, providing useful work to the engine. Exhaust. The waste chemicals get output through the exhaust port and the cycle repeats. While there are many kinds of internal combustion engines, the four-stroke piston engine is one of the most common. Second, we have gas turbine engine. The basic principle of the aeroplane turbine engine is identical to any or all engines that extract energy from chemical fuel. The basic four steps for an internal combustion engine are intake of air, possibly fuel, compression of air and possibly fuel, combustion where fuel is injected if it was not drawn in with the intake air, expansion and exhaust where the converted energy is put to use. The turbine section of the gas turbine engine has the task of reducing usable output shaft power to drive the propeller. In addition, it must also provide power to drive the compressor and all engine accessories. It does this by expanding the high temperature, pressure, and velocity gas and converting the gaseous energy to mechanical energy in the form of shaft power. Both engines work on the same basic principle: suction or induction, squeeze or compression, bang or power, flow or exhaust. Both turboprops and jets are powered by turbine engines, so they are essentially the same thing and thus are considered to be equally as safe. The main difference is the turboprops have propeller on the outside of the engine while jets have fan blades inside the engine housing. Propellers are efficient at lower speed, thus created by accelerating large amount of air at low velocity. Jet propulsion is efficient at faster speeds, thrust created by accelerating small amount of air at high velocity. Hence, RC aircraft need propeller-driven engines for low speed. Let us see the difference between fuel engine and electrical engine. Fuel engine needs moderate maintenance, has moderate to high repairability chance, essential field items need to start and run the engine, flight time depends on fuel tank size, it is noisy and messier and more expensive. whereas electrical engine needs very little maintenance and is straightforward and simple repairability. Spare battery and a good charger is needed the most. Flight time depends on battery capacity. It is quiet and clean and comparatively less expensive. Now, let us move to the types of engine. Glow engine. Glow plug is a durable, mostly platinum helical wire filament recessed into the plug's tip. When an electric current runs through the plug or when exposed to the heat of the combustion chamber, the filament glows, enabling it to help ignite the special fuel used by these engines. Gasoline engine is a type of heat engine, especially an internal combustion that is powered by gasoline. These engines are the most common ways of making motor vehicles move. While turbines can be powered by gasoline, a gasoline engine refers specifically to piston-driven gasoline engines. Diesel engine works by compressing only the air. This increases the air temperature inside the cylinder to such a high degree that atomized diesel fuel injected into the combustion chamber ignites spontaneously. Diesel engines may be designed as either two-stroke or four-stroke cycle. Jet engines move the aeroplane forward with a great force that is produced by a tremendous thrust and causes the plane to fly very fast. All jet engines, which are called as gas turbine, work on the same principle. Wankel engine is an internal combustion engine. Unlike the piston cylinder arrangement, this engine uses the eccentric rotor design, which directly converts the pressure energy of gases into rotary motion, while in the piston cylinder arrangement, the linear motion of the piston is used to convert into rotary motion of the crankshaft. Basically, in a simple way, the rotor revolves in housing shaped in a fat figure of 8. Pulse jet engine works by alternatively altering a contained mass of air rearward and then breathing in a fresh mass of air to replace it. Energy to accelerate the air mass is provided by the deflagration of fuel mixed thoroughly into the newly acquired fresh air mass. Now let us see the difference between brushless and brushed motor. Brushed motors are 75% to 80% efficient. They are used for low-speed aircrafts, have an average lifetime, are low cost and more audible sound. Brushless motors are 85 to 90% efficient and are used for high-speed aircrafts. They have a very long lifetime and are of high cost but less audible noise. Motor characteristics. Outrunner. The term outrunner refers to a type of brushless DC electrical motor primarily used in electrically propelled radio-controlled model aircraft. This type of motor spins its outer shell around its winding, much like motors found in ordinary CD-ROM computer drives. With an outrunner motor, the magnets are attached to the ring and the sleeve on the outside of a stator coil. As a result, the motor has a rotating ring or sleeve instead of a rotating shaft. In runner, with conventional motors, the magnets are attached to the shaft that rotates on the inside of the stator coil. The term in runner refers to an electric motor where the runner or the motor is inside the stator. The term is in a particular for brushless motors to differentiate them from outrunners that have their rotor outside the stator. An advantage of an outrunner motor compared to an inrunner motor is that the air gap surface is substantially larger. In other words, the surface area through which the electromagnetic field lines pass from rotor to stator is much larger. This way, more electromechanical force is generated. kV, it is related to the power out from the motor. kV describes the RPM a motor does per volt that is put into it. Generally speaking, more kV a motor has, more RPM and more power. Now let us discuss some terms of motor. RPM. RPM is a measurement used to describe a motor speed. It stands for revolutions per minute and describes the rate at which the motor is revolving, which is the number of times the rotor shaft completes a full rotation each time. kV is the number of revolutions per minute that a motor turns when 1 volt is applied without load. Do not confuse with kV, which represents kilovolt with a capital V. kV rating determines how fast the motor will rotate when the voltage is applied to it. Let us see an example. To find the RPM of a 980 kV motor powered by 11.1 volt battery, RPM is equals to kV of motor into V of battery. We get 10,878 RPM. A change in voltage will change the RPM. A low kV motor has more windings of thinner wire and has more volt at few amps, gives high torque to swing bigger propeller at low revolutions. High kV motor has less winding of thicker wire, has more ampere at few volts, and which is used for low torque to swing small propellers at high revolutions. Let us see an example. High-speed aircraft requires high RPM for high speed. Hence, we will be using high kV motors which can rotate small propeller diameter to give a low torque. On the other hand, low-speed aircraft requires low RPM for low speed, which in turn will be using low kV motor which can rotate larger diameter propeller to give high torque. As combustion engine RPM increases, it reaches a maximum torque. Later, due to increase in mechanical friction, the engine cannot inject enough air as suction stroke is quicker than the actual air sucked in. Thus, the compressor reach their maximum speed and can't deliver enough air needed for RPM, hence torque reduces. As an electric motor, it has constant maximum torque from 0 RPM as they have less moving parts and less friction to overcome. At a specific RPM, the electromotive force produces resistance that results in drop of torque. Every engine has its own torque range. Weight and dimension of aircraft must be known for choosing the motor. Larger and heavier powerful motors should be preferred. So we have different aircraft type and the power watt per lb. Trainer model and slow flying model needs a power of 70 to 90. Sports and fast flying aerobatic model needs 90 to 110. Advanced aerobatic and high speed model needs 110 to 130 of power. Light loaded 3D model and ducted fan needs 130 to 150 power. Unlimited performance model needs 150 to 200 plus watt per lb of power. Thrust to weight ratio. Thrust to weight ratio is directly proportional to the acceleration of the flight. High thrust to weight ratio results in high acceleration. 1:1, which is the best for normal flight. 0.5:1, thrust is half of weight. 0.3:1 to 0.5:1 is for model aircraft. 0.5:1 to 0.8:1 is for trainer models. 0.8:1 is for fast moving models. Let us see an example. If an model aircraft is 1.2 kg and is a trainer plane, then we use the thrust to weight ratio of 0.7:1. Now, replacing the 1 by 1.2 kg plane, we get 0.7:1.2. By multiplying both, we get 0.84 kg, which is 840 grams. Thus, 840 grams is the thrust required for a trainer plane. To calculate the thrust of a model plane, we have to replace the 1 which is on the right side of the ratio by the weight and multiply the numbers on the left with the weight. Stall speed, it is the minimum speed that produces lift in an aircraft. If aircraft drops below the stall speed, then it will no longer produce lift. Aircraft should fly 2.5 to 3 times faster the stalling speed. Stall speed is 4 to 5 times the root chord of the wing loading. Here we have the formula for finding the thrust of a flight using the dimension of propeller and RPM of motor. F thrust in newtons, RPM propeller rotation per minute, pitch propeller pitch in inch, D propeller diameter in inch, V0 forward airspeed in mass per second. Example: an aeroplane has 10 into 6 propeller, that is 10-inch diameter and 6-inch pitch. spinning at 1600 rpm at full throttle. How do you find the thrust produced? By using the above equation, we get F is equals to 1.617 kg. As we know, the thrust of the flight should be equal to the weight of the flight. Hence, this thrust will be able to carry a flight of approximately 1.6 kg. I hope you guys would have understood today's session. As of now, we are completely done with the theory of RC plane model. Let us start building your model in our next session. Thank you.